National Electrical Code, or NEC, addresses the use of junction boxes on dedicated appliance circuits. Specifically, the question arises whether it's permissible to install a junction box on a dryer line, range line, or dedicated dishwasher line solely for the purpose of extending it during a remodel. The NEC generally does not permit the installation of junction boxes within these dedicated appliance circuits for the purpose of extension. The code emphasizes the importance of a continuous run from the service panel, also known as the breaker panel or electrical panel, to the appliance itself, without any intermediate splices or junction boxes. This requirement is rooted in safety and efficiency considerations. Firstly, the concern with introducing a junction box into a high-current circuit, such as those serving a dryer, range, or dishwasher, lies in the potential for increased resistance at the connection points within the box. Electrical connections, even when properly made, introduce some amount of resistance to the flow of current. This resistance generates heat, and excessive heat can lead to insulation breakdown, loose connections, and ultimately an increased risk of electrical fire. Secondly, the integrity of the grounding path is crucial in these circuits. A continuous run of wire ensures a low impedance grounding path, which is essential for quickly clearing faults and protecting against electrical shock. Introducing a junction box can compromise this grounding path if the connections are not properly made or maintained. Thirdly, the NEC aims to minimize the number of potential points of failure in electrical systems. Each connection within a junction box represents a potential point of failure, and by requiring a continuous run, the code reduces the overall risk of problems arising over time. When a remodel necessitates extending one of these dedicated appliance circuits, the proper approach is to run a new, continuous cable from the service panel to the new appliance location. This ensures compliance with the NEC and maintains the safety and reliability of the electrical system. Installing a new circuit involves several steps. 1. Determining the appropriate wire gauge and overcurrent protection for the appliance. The NEC provides tables and guidelines for selecting the correct wire size based on the ampacity of the circuit and the type of insulation. Similarly, the overcurrent protection device, such as a circuit breaker or fuse, must be sized appropriately to protect the circuit from overloads and short circuits. 2. Running the new cable from the service panel to the appliance location. This may involve drilling holes through studs or joists, and the cable must be properly secured to prevent damage. 3. Making the connections at the service panel and the appliance. These connections must be made in accordance with the NEC and using approved methods and materials. It's important to note that working with electrical systems can be dangerous, and it's always recommended to consult with a qualified electrician if you're not comfortable performing the work yourself. In some cases, there may be specific exceptions or allowances within the NEC depending on the specific circumstances. However, the general rule is that continuous runs are required for these dedicated appliance circuits. It's always best to consult the latest edition of the NEC and seek guidance from a qualified electrical inspector or engineer if you have any questions or concerns. The NEC is a comprehensive document, and understanding its requirements can be challenging. However, by following the code and seeking expert advice when needed, you can ensure the safety and reliability of your electrical system. Consider the specific NEC articles and sections relevant to appliance circuits. While a general prohibition against junction boxes for extensions exists, it's crucial to review the specific wording of the NEC for the applicable edition in your jurisdiction. Pay attention to articles covering branch circuits, wiring methods, and appliance installation. These sections often contain detailed requirements and exceptions that may apply to your specific situation. The NEC often refers to listed appliances. This means the appliance has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. Listed appliances are required to be installed according to their listing, which may include specific requirements for wiring and connections. Check the appliance's installation instructions for any specific requirements that may affect the installation of the circuit. When extending a circuit, consider the existing wiring. If the existing wiring is old or damaged, it may be necessary to replace it entirely rather than simply extending it. Old wiring may have deteriorated insulation, which can increase the risk of electrical shock or fire. If you're unsure about the condition of the existing wiring, it's best to consult with a qualified electrician. Remember that electrical codes and regulations can vary depending on your location. It's essential to check with your local building department or electrical inspector to ensure that you're following the correct requirements. They can provide guidance on specific local amendments or interpretations of the NEC. The requirements for kitchens and laundry rooms are very specific. Pay attention to the NEC requirements for dedicated circuits, receptacle spacing, and ground fault circuit interrupter, or GFCI, protection in these areas. These requirements are designed to enhance safety in areas where water and electricity are likely to come into contact. GFCI protection is typically required for all receptacles serving countertop surfaces in kitchens, as well as for receptacles in laundry rooms, bathrooms, and outdoor locations. Consider the long-term implications of any electrical work you perform. Proper wiring and connections can last for many years, while faulty work can lead to problems down the road. Invest in quality materials and take the time to do the job right. If you're not sure about something, don't hesitate to ask for help from a qualified electrician. Think about future needs. When extending a circuit, consider whether you might need additional capacity in the future. It may be wise to install a larger wire gauge and a higher amperage circuit breaker than is currently required to accommodate future electrical loads. This can save you the expense and hassle of having to upgrade the circuit later on. Also, consider the impact of your electrical work on other building systems. For example, running new wiring may require you to modify or relocate existing plumbing or HVAC systems. Coordinate your work carefully to avoid conflicts and ensure that all systems are properly installed and functioning correctly. Don't forget about proper labeling. Clearly label all circuits in your service panel to indicate their purpose. This will make it easier to identify and troubleshoot problems in the future. Use a permanent marker or label maker to create clear and legible labels. Also, label any junction boxes or other electrical enclosures to indicate the circuits they contain. Consider the aesthetics of your electrical work. While safety is the primary concern, it's also important to make sure that your wiring and connections are neat and professional looking. Use proper techniques for routing and securing cables, and avoid creating unsightly messes. Conceal wiring whenever possible, and use appropriate cover plates and enclosures. When working with electrical systems, it's always better to be safe than sorry. If you're not sure about something, don't take chances. Consult with a qualified electrician or electrical inspector to get the information and guidance you need. The NEC is updated regularly, so it's important to stay current with the latest requirements. The NEC is typically updated every 3 years, and each new edition may contain significant changes that affect electrical installations. Subscribe to industry publications or attend continuing education courses to stay informed about the latest code changes. Electrical safety is everyone's responsibility. By following the NEC and taking the necessary precautions, you can help to prevent electrical accidents and ensure the safety of yourself and others. If you see something that doesn't look right, don't hesitate to report it to a qualified electrician or electrical inspector. Remember that electricity is a powerful force, and it should be treated with respect. If you are extending a dedicated appliance circuit, make sure to consider voltage drop. Voltage drop is the decrease in voltage that occurs along the length of a wire due to its resistance. Excessive voltage drop can cause appliances to operate inefficiently or even fail prematurely. The NEC provides guidelines for calculating voltage drop and specifies the maximum allowable voltage drop for different types of circuits. When extending a circuit, it's important to calculate the voltage drop to ensure that it remains within acceptable limits. If the voltage drop is too high, you may need to use a larger wire gauge or install a separate circuit. Ensure proper grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. Bonding connects all metal parts of the electrical system together, which helps to equalize their potential and reduce the risk of shock. When extending a circuit, it's important to maintain proper grounding and bonding. Make sure that all grounding and bonding connections are made in accordance with the NEC. Use appropriate wiring methods. The NEC specifies different wiring methods for different applications. For example, non-metallic sheath cable, also known as Romex, is commonly used for residential wiring, while conduit is typically used for commercial and industrial wiring. When extending a circuit, it's important to use the appropriate wiring method for the application. Follow the NEC requirements for the type of cable or conduit, the number of conductors allowed in each raceway, and the methods for supporting and securing the wiring. If you are working with aluminum wiring, take extra precautions. Aluminum wiring was used in some homes built in the 1960s and 1970s, and it has been found to be more prone to problems than copper wiring. Aluminum wiring can corrode and loosen connections, which can lead to overheating and fire. If you have aluminum wiring in your home, it's important to have it inspected by a qualified electrician and take steps to mitigate the risks. This may involve replacing the aluminum wiring with copper wiring or using special connectors designed for aluminum wiring. Use approved materials and equipment. The NEC requires that all electrical materials and equipment be listed and labeled by a recognized testing laboratory. This ensures that the materials and equipment have been tested and found to be safe for their intended use. When extending a circuit, use only approved materials and equipment. Don't use substandard or counterfeit products, as they may not meet safety standards and could pose a fire or shock hazard. Consider energy efficiency. When extending a circuit, take the opportunity to improve energy efficiency. Use energy-efficient lighting and appliances, and install occupancy sensors or timers to turn off lights when they are not needed. This can help to reduce your energy consumption and save money on your electricity bill. Think about future expansion. When extending a circuit, consider whether you might need to add additional outlets or fixtures in the future. It may be wise to install a larger junction box or run a spare wire to accommodate future expansion. This can save you the trouble of having to extend the circuit again later on. Plan for accessibility. Make sure that all electrical components, such as junction boxes and circuit breakers, are easily accessible for maintenance and repair. Don't bury junction boxes behind walls or ceilings, and don't block access to the service panel. Proper planning and accessibility can make it easier to troubleshoot and repair electrical problems in the future. Document your work. Keep a record of all electrical work that you perform, including the date, the scope of the work, and the materials used. This documentation can be helpful for future maintenance and repairs, and it may also be required by your local building department. Take photos or videos of your work before you cover it up, as this can be helpful for troubleshooting problems later on. Consider surge protection. Surge protection can help to protect your electrical equipment from damage caused by power surges. Power surges can be caused by lightning strikes, utility switching, or even appliances turning on and off. Install surge protection devices at the service panel and at individual outlets to protect your sensitive electronic equipment. Think about home automation. If you're extending a circuit, consider adding home automation features, such as smart outlets, smart lighting, or a smart thermostat. These devices can help you to control your home's electrical systems remotely and save energy. Consider the impact on resale value. Upgrading your electrical system can increase the value of your home. Potential buyers will appreciate a well-maintained and up-to-date electrical system. Make sure to document all electrical work that you perform, as this can be valuable information for potential buyers. Always disconnect power before working on any electrical circuit. Identify the circuit breaker that controls the circuit you'll be working on and turn it off. Use a voltage tester to verify that the circuit is de-energized before you begin working. This will help to prevent electrical shock. Wear appropriate personal protective equipment. When working with electricity, it's important to wear appropriate personal protective equipment, such as safety glasses, rubber gloves, and insulated tools. This will help to protect you from electrical shock and other injuries. Work in a well-lit area. Working in a well-lit area can help you to see what you're doing and avoid mistakes. Use a flashlight or work light if necessary. Avoid working in damp or wet conditions. Water is a good conductor of electricity, so working in damp or wet conditions can increase the risk of electrical shock. Make sure the area is dry before you begin working. Follow all safety precautions and manufacturer's instructions. Always follow all safety precautions and manufacturer's instructions when working with electricity. Read the instructions carefully before you begin, and don't take shortcuts. Double check your work. Before you restore power to the circuit, double check your work to make sure that all connections are tight and that everything is properly installed. This can help to prevent problems down the road. Have your work inspected. If you're not sure about something, or if you've made any significant changes to your electrical system, have your work inspected by a qualified electrical inspector. This can help to ensure that your work is safe and complies with all applicable codes. These guidelines emphasize the importance of safety, code compliance, and best practices when working with electrical systems, particularly when extending dedicated appliance circuits.